Alrighty, Year 10. Because we had such an interruption to this week, I'm going to start from Monday's lesson and move from there. So I'm pretty sure nobody's got all the work done from Monday's lesson. So I want to start by just making it clear what was required for Monday's lesson, and then you guys can start working on that. So I would like us to be on target though, so over the next couple of hours I'll be bringing out the videos necessary to get you up to Thursday's and probably Friday's lesson. So just starting back here with lesson 2, and I've deleted everything off OneNote here, so I'm going to start by going through this again. And one of the things that we do with Surds is most of the rules of algebra will still apply. So if I had 2x plus 5x, most of you, I'm sure by now, are pretty comfortable with the idea that that equals 7x. 2 lots of something plus 5 lots of something equals 7 lots of that same something. And by the same token, I think most of us are pretty happy with the idea that 2x plus 3y plus 5x equals 7x plus 3y. In other words, I have to have like terms. Surds work just the same. In order to add or subtract, we have to have like surds. The only difference here is that sometimes it might look like we don't have like surds, but first we need to simplify the surd, and we might find that we do actually have like surds. So just going through these first examples, I've got 2 root 3 plus 5 root 3. So I've got 2 lots of root 3 plus 5 lots of root 3. If I add that together, I'm going to end up with 7 lots of root 3. Remember, there's a missing multiplication sign in there that we don't put. Just like we don't put a multiplication sign between 2 and x, we don't put a multiplication between 7 and root 3. 7 root 3 means 7 times root 3. So just moving on to the next question, I've got root 7 minus 12 root 7, so I've got 1 lot of root 7 and I'm taking away 12 lots of root 7, so I'm going to end up with negative 11 lots of root 7. Getting into the next question now, we've only got so many like terms now. They're not all the same like terms. So this is a like term with that one because they're both written multiplying by root 5. And our other 2 terms on here are not like terms. So we've got to deal with them much like we would deal with algebra. We deal with the like terms together. So just going with that, 12 minus 4, well, that's going to be 8. And minus 1 lot of root 5 plus 3 lots of root 5 is going to give me 2 root 5. Okay, similar scenario here. Let's go with our like terms. 3 root 2 and 3 root 2 are like terms. And negative 5 root 3 and negative root 3 are like terms as well. Remember that every single number owns the sign in front of it. So that's not a 5 root 3 with a negative in front, it is a negative 5 root 3. So as we work through this, I've got 3 lots of root 2 plus 3 lots of root 2. Well, that's going to be 6 lots of root 2. And minus 5 lots of root 3 minus another lot of root 3 is going to give me minus 6 lots of root 3. Moving into this next set of questions now, we're dealing with situations where it looks like we don't have like surds, but maybe we do. So just starting with, well, root 20, I could, I'm just going to do this sort of here. Well, that's the same as the square root of 4 times 5. 4 times 5 is 20, so I can write the square root of 20 as the square root of 4 times 5. And of course, 4 is a square number. So if I take 4 out of the surd, I've got to take the square root of 4 as I take it out. So the square root of 4 is 2, and I'm left with 2 root 5. Root 80, on the other hand, is also has 4 as a factor, although I think there's possibly a better one we can use. Just 1 second, I have to pause. Sorry about that, I had to have a cough. So root 80, I could, certainly 4 goes into 80, it goes into 80 20 times, but then I know that 20 is not the most simple form, so I think there's a larger number I can use, and in this case it's 16. So I could write root 80 as the square root of 16 times by 5. Now, if you don't see that straight away, that's fine. You can just, what we should get in the practice of doing is dividing numbers by square numbers up to sort of half the value of that number, and we might find one that's better. Alternatively, it would still work out if I'd done that as 4 times 20 and then dealt with root 20. So as I take 16 out of the surd, I have to take the square root of that number. So I'm going to end up with 4 root 5. So now I can write this whole thing here as if what I've essentially got here is 4 lots of 2 root 5 minus 3 lots of 4 root 5. Because I've simplified and we worked out that root 20 is 2 root 5 and root 80 is 4 root 5. And obviously I can't throw away these numbers in front. So 4 times 2 is 8, so that's going to be 8 root 5, not root 8, minus 12 root 5. So that's just going to equal, well, they're both expressed as root 5, so I can just add and subtract. They're like surds. So 8 minus 12 is going to give me minus 4 root 5. All right, I'll go a little bit quicker with this next couple, just so we get through enough. So the square root of 27, I can't really express, they're not, the square root of 27 and the square root of 12, they're not the same surds, but 9 goes into 27, and that goes in 3 times. So the square root of 9 is 3. So the square root of 27 is the same as 3 root 3, because 3 times 9, but I take the square root of 3. So I've just sort of skipped a step there. And in this one, the square root of 12, well, 4 is a factor of 12. So that's 4 times 3. So I'm going to have the square root of 4 times the square root of 3. And the square root of 4 is 2. And then I've got to multiply by what's out the front. So 2 times 4 is 8 root 3. If you're not quite sure how I got to those, go back and have a look at the first lesson on simplifying surds and do some more of those exercises. 3 minus 8, however, well, that's just going to be negative 5 root 3. Okay, and as we go on from here, we have to deal with fractions as well. The same process applies with all fractions. We just need to find a common denominator to add or subtract. So likewise, with surds, we're going to be looking to see if we can get them simplified into the same surd. If we can do that, then we can find a common denominator and add and subtract. So I don't think there's much I can do with 2 root 3. I'll just write that one again. That's about as simple as I can get that, because the square root of 3 is as simple as I'm going to get that one. But the square root of 27 can be expressed as the square root of 9 times 3. So what I'll end up with is 3 lots of 3 root 3. Because 9 times by 3 is 27, I take the square root of 9, I get 3 over 5. So I'll simplify this all out at the moment. So I've got 2 root 3 on 2 minus 9 root 3 on 5. Now, although surds are involved, really what I'm dealing with is a year 7 fraction problem. I'm dealing with, let's get a common denominator and let's work out an answer. So the best common denominator to use in this case would be 10. Because 2 times 5 is 10, it's going to be the lowest common denominator that would work. So what did I do to get this 2 to become a 10? I had to multiply this by 5, which means I have to multiply the top by 5. And to get this 5 to become a 10, I had to multiply the bottom by 2, so I'll have to multiply the top by 2. So 5 lots of 2 root 3 is just going to be 10 root 3. And 2 lots of 9 root 3 is going to be 18 root 3. And so when I add them all up, I'm going to end up with 10 minus 18 is going to give me minus 8 root 3 on 10, but I think I can do a bit better than that. I think I can simplify that. 2 goes into both negative 8 and 10 goes into negative 8 negative 4 times, and it goes into 10 5 times, and that looks a little bit more simple. So negative 4 root 3 on 5. And our final example here, once again, it looks like we don't have like surds, but whenever they can be simplified, simplify them first, see if we can we can add or subtract them. So if I deal with this over here, the square root of 200, well, that's going to be the same as the square root of 100 times 2. 100 is a square number, so I can take the square root and put it at the front. So the square root of 200 is 10 root 2. The square root of 8, on the other hand, well, that can be expressed as 8. It can be expressed as 4 times 2. Because 4 is a square number, we take the square root and put it out the front. So the square root of 8 is 2 root 2. The square root of 200 is 10 root 2. I'll just put those in a little box to the side so we can use those. If you like doing it that way, just work out your surds first, you can. So as I change this one, I'm going to end up with 10 root 2 on 3 minus 5 lots of 2 root 2. So that's actually going to be 10 root 2 as well on 4. Now that's not, I can't just add and subtract those. It looks very similar at the top, but of course it's the denominators that need to be common. So the best common denominator to use here would be 12. So I make both fractions over 12. Once again, whatever I multiplied the bottom by, 3 times 4 is 12, I've got to multiply the top by. And whatever I multiplied this bottom by, I have to multiply the top by as well. So as I do that, I'm going to end up with 40 root 2 minus 30 root 2. So it's all going to end over 12, and we're going to have 40 minus 30, so that'll be 10 lots of root 2. And in this particular case, I can see that 2 goes into both 10 and 12. It goes into 10 5 times, so I'll end up with 5 root 2, and 2 goes into 12 6 times, so I end up with 5 root 2 on 6. Okay, so make sure you have a go at those questions. In particular, as I go to the textbook, obviously pick your line there as far as where you want to go, but the real key questions that you're going to hit in this particular exercise is going to start with question 5, 6, 7, 8 and 9. You really want to make sure you do enough of 5, 6, 7, 8 and 9 to know that you get this stuff. So I'll just write that down the bottom here. Focus on questions 5 through 9. So with that, if you're getting them, great, do half maybe and go on to the next lot. If you're not getting them, do more of them, okay? We will be expected to work with Surds throughout other topics this year. You need to get this stuff good in your head. So that's it for this lesson. I will now do the multiplying and dividing lesson next, so you know where we're going there. Have a good day.